Good morning guys, I hope you're well. In today's lesson we're going to be learning how to recognize and continue Fibonacci sequences. The first thing I would like you to do is consider the numbers on your screen. I'm going to tell you these numbers are not a linear sequence and they are not a geometric sequence. I'd like you to pause the video and see if you can tell me what is the rule that takes me from each term to the next term. What is happening each time? Well, this is a very famous set of numbers. This is the most famous Fibonacci sequence. By a Fibonacci sequence, what we mean is that each term is the sum of the previous two terms. Let's have a look at this term 2. Do we notice that this term 2 is just 1 and 1 added together? So 1 and 1 makes 2. Think about how we got this term 3. 1 plus 2 makes 3. How did we get the term 5? Well, 2 add 3 makes 5. How do we get the term 21? Well, 8 plus 13 makes 21, and so on. So a Fibonacci sequence means that each term is just the two terms before it added together. Something very interesting happens when you try and sketch these numbers on a grid. So if I have a square grid like this, let's take my first term 1. Let's say 1 represents a 1 by 1 square. Let's add another 1 by 1 square to my grid, because 1 is the second term in my sequence as well. The third term in my sequence is 2. Let's add a 2 by 2 square to this diagram. The next term is a 3. Let's add a 3 by 3 square to this diagram. Do you notice that the 3 by 3 square is going to fit perfectly on top of what I've got so far? Now let's add a 5 by 5 square. Do you see how I could perfectly slot this in? So this 5 by 5 square can go here, and now I can add my 8 by 8 square. Every time I add a term, this new shape is going to fit perfectly on my grid. I'm going to stop there just because I don't have enough room to fit the 13 on my grid, but hopefully you can see that it starts to form that very interesting pattern. This pattern is a very famous pattern called the golden ratio, which appears all the time in nature. So this golden ratio, so this spiral pattern, it appears all the time in nature. So it's a natural phenomenon. So one of the most common examples is you'll see it in snail shells. So you see it all the time in nature, and plants and things like that. So the guy who painted this very famous painting called the Mona Lisa, so he was called Leonardo da Vinci. He was also a famous mathematician, and he was a big fan of this golden ratio, and he used the golden ratio. He considered it when he was painting this, and that's one of the reasons why it's widely considered as one of the most beautiful paintings of all time. Okay, so if you go on to study maths at university, you'll understand that the golden ratio, it helps govern natural things we see in the universe, like hurricanes. So you also see the golden ratio in galaxies, and you'll also see the golden ratio in Donald Trump's head. Okay, so the human body also perfectly fits that golden ratio, and you can try this for yourself. So if you consider the bones in your hand, they ascend in that kind of Fibonacci sequence of 2, 3, 5, 8 in length. So if you're interested in this, there's a guy on YouTube who's actually encoded the Fibonacci sequence into a piece of music. So he's taken those numbers and written them on his piano, and he's played a piece of music. So I'll send you that link on Google Classroom if you are interested, but that part's completely optional, it's up to you. So find the next two terms of this Fibonacci sequence. So Fibonacci sequence literally just means add together the previous two terms to get the next one. Alright, so 12 plus 19 gives me 31, so that's my next term in this sequence. And then to get my final term, well, I'd need to take those last two terms. I need to take 19 and 31, add them together to give me 50. Okay, let's try some harder ones. If you just want to try it yourself, just pause the video and crack on with it, that's fine. Equally, if you just want to listen to me explain it and talk you through it, please just leave the video running. So for question 1, let's write down the next two terms of this sequence. So I've got 3 terms, I need to find the next 2. So just because it's algebra, that shouldn't scare us off. We know how to add together algebraic expressions, don't we? So let's take the last 2 terms we've got so far. So I need 2y and 2x and 2y. I need to add them together. So 2y plus 2x plus 2y collect my like terms. 2y plus 2y gives me 4y, and I've also got 2x. So this red term is my fourth term. And then finally, to get my fifth term, I need to take this 2x plus 2y term and add it to 2x plus 4y term. So just adding together those last two terms. So it's going to be 4x plus 6y. And that would give me full marks if that was a question in my exam. Okay, so let's try the next one. So a Fibonacci sequence has a second term of 20 and a fifth term of 80. Find the first term. This one's not really as straightforward, so we're going to have to use some problem solving skills here. This sequence, it goes up to the fifth term, so all I'm going to do, I'm just going to write 5 blank spaces and just fill in what I know so far. So I know that the second term is 20, so let's add a 20 in that second space. And I'm told that the fifth term is 80, so I'm just writing that there just so I can see what I've got. Okay, so the question is, we'll find the first term. Well, I want you to ask yourself, well, what would a mathematician do when they don't know the value of something? So predict what I'm going to do now. So if I don't know what something's called, what would a mathematician do? Okay, so if we don't know what something is in maths, we're just going to call it x, right? So x is just an unknown. We use algebra when we don't know things. So if I don't know what that is, let's call it x. Okay, I'm not quite sure what x is yet, so let's just fill in what we can. Look at this third place. Again, we don't know what it is, but I can use what I know about Fibonacci sequences to write some maths here. I'm not going to introduce any other letters. I'm not going to use y's or anything like that. That's going to look a mess. Let's write it in terms of x. Can you think how to do that? Okay, so in this third space, what I'm going to do, I'm going to add together my first two terms. So x plus 20 will be my third one because I've just added together those two previous terms. Again, I want you to think, well, what must go here? So we're not adding any other letters. Like I said, keep it in terms of x. It's easier when there's just one variable. Okay, so I need to take 20 and I'm adding on x plus 20. So this will be x at 40, right? Okay. Now I have enough information for me to solve for the value of x. I'm going to make an equation here. I know that my last term is 80 and we have expressions for these two. So what I can say is that my third term and my fourth term add together to equal 80. Can you make an equation out of that? So x plus 20 plus x of 40 equals 80 because the previous two terms must add together to give the next term. Okay, well, let's simplify. So x and x gives me 2x and 20 and 40 gives me 60. So I've collected my like terms and now I've got an easy equation to solve. Subtract 60 from both sides. So 2x is a 20, which means that 1x must be 10. And I've solved the problem. Let's just check that that works. Okay, so if x is 10 or x plus 20, well, that will give me 30 and x plus 40 should give me 50. Does this fit the rule? Well, 20 or 30 makes 50, that works. 30 and 50 gives me 80, so that's fine, and I've solved the problem. So the first term is 10, that is my answer. If you look at your attachment on Google Classroom, you will find your classwork for today. So you've got exercise 1, which is just number questions, and exercise 2, which is those algebra questions. Okay, any questions, just let me know as always, and thank you very much.